Thank you, everybody, for being here at Depop. It's really nice to receive the Android here. And I will talk about our architecture on the Depop code, that we use MVP, why we use MVP, and how we use MVP. And before we started, it's very important to understand a little bit about our legacy code, because because of our legacy code that we decided to use MVP. As you can expect, touching our legacy code was very painful, and this taught us a lot. So our code base and why we decided to split in models. Our legacy code was something that was made 6 years ago, something like that, already passed for a version 2 of the legacy code. So this is the phase that you have on the legacy code, a lot of models. I will open just one of them, so you can understand a little bit why we go forward. I will open the version 2, because the version 2 is already an improvement. So in the version 2, you already have a little bit of the MVP structure that we would expect it, and then you open the app, and then you open the core, and then you open the data, and if you want to find messages somewhere around, and then you have this kind of class. Because everything is quite dependent. So you go to one class and you can find 7 starts, a lot of make intents, and different places calling. And you say, yeah, I'm going to change something, and the code say no. So it's quite hard, make us like scream sometimes. And what we realize about our legacy code, as I said, is very sensible. So if you go to one of your screens and you want to change something, you affect a lot of parts of your code. And you're quite lucky when something broke, because you can fix it. You're very bad when something don't broke, and you fix it live. It's hard to use. Since everything is so dependent of each other, you have a specific flow for some parts of the code, and they can only be used in a specific flow. So if you want to open that fragment that lives inside another fragment, inside an activity, you need to open the whole flow to get on that. And we start to see that what is our longevity goal on our Depop code base. If we go in the future, our utopia about what we want to have would be great if we can have a fragment-based app. It means what? Each fragment that you have in your app, you can call it for another fragment. Thinking about that, we start to modularize our code. We start to split it very specific. Each feature has its own domain, its own model, and each one of them has the MVP architecture that we work on. So we have great moments here, because our code, as any code that was wrote 6 years ago, was mostly only Java. And when we see this, that we have 6% of our code in Kotlin, even 6.1% today. We improve it a lot. This represents us that we have the new architecture on Kotlin. So on November last year, we have 50% in Kotlin, and now we achieved 60%. It's coming an improvement about our architecture and how our code is modularized. So let's go. Let's show you what I'm talking about and how we split and use the MVP. Our MVP, we used 4 main layers. We have the view layer that is responsible for the UI elements, fragments, view, adapter, recycle. It should hold all the Android elements like context, so we have a really good division about where Android lives, and the rest of our code is dumb as possible, so we put no logic in the view. If we just say do it and the view do it, it's perfect for us. And it's the layer that is responsible for the interaction with the user. So when the user does something in our app, it's the view layer who will receive this. Our second layer is the present layer. It holds our model that represents what we want to show for the user on the screen. It holds our domain, our entity, that is the rules that we have inside our feature. It deals with the threads, so the concurrence that code just presents us is made on the domain. In our case of the MVP, and we'll talk about MVVM a little bit later, we take care of the life cycle, so we know exactly what the view is doing. We have control over it. And in our code base, if we need to hold a state somewhere, for example, you decide to rotate your view, or you go out, is the presenter in our architecture that holds a state. Then we have the core layer. The core layer is one of the is the most important layer that we have. It has our domain rules, so everything that we need to use it on this feature. It holds our business logic, is immutable, stable. So when we talk about our core, we try to make it very stable. So if you change something in the core, it's because you changed something in the whole feature. And you should think about that. This helps us to do code review. This helps us to make improvements, to make refactors on the code. We have the contract, as Colby touched a little bit. The contract that we have on Depop, it's decide what we're going to have in each one of the layers and how they will communicate between themselves. This helps us to have something, as I said before, sorry to be redundant on that, but it's stable. And this helps us to make code reviews to understand what expected that the function is doing and what expected the function will return. And the core layer doesn't care about the other layers. So no, he don't depend on anyone else, and all the other layers depends on the core. And in the end, we have the data layer that deals with different data sources, APIs, local databases, share preference, everything that you want. Get these DTOs, the data that we receive from different repositories or data sources, put all together and send to the core layer. So I will present how we build it, this. We have the presenter, the core, the app, and the data. And the first thing that we decide is about our contract. What is our contract? It's mostly an interface that decides how we're going to communicate between the layers. Then we have the main implementations. I put here quite simple, so we have more things. We have like fragments, the activity, the recycle, the adapters, but for you to understand the main ones, each one of these implementations, they will be connected with one of the interfaces. So the green arrow that is empty is when you implement, and the white arrow that is full is when you consume. So here you can easily see that the view is consuming the presenter to have a communication directly with the view and with the interactor. The interactor has a communication directly with the repository and a response to the presenter. Beside that, in our architecture, we have our data classes. So we have our model in the presenter that will show on the view what we expected. We have our domain that, as part of the core, is very stable and define our rules. And we have our mappers. In Depop, we try not to have rules that cannot be changed. We are always open, like, to do things different. If you come with a different mindset, you have a strong opinion about something, we discuss and we check case or case. But we try not to put mappers inside the core, because with this structure, if you change something on the UI, you're not changing your core. If you change something on your API, you're not changing your core. If you change something about how you make the presentation of the data that you have, you're not changing your core. And this is very important for us, so we can have stability. So with this structure, your view is accessible for any other view in the app, so you can have an easily communication and you can have easily access. And then we have one more point that is very important about our structure, is the service layer. The service layer is where we hold our APIs, where we hold our database, where we hold our DTOs, the data that we need to transfer, and our data layer will talk with the service, and then become a little bit messy. But how we do at Depop? As I said on the beginning, we try to modularize everything. So when you have a feature that has a structure about the MVP, and we have a service that is another structure, we split it. So we have a lot of small boxes on Depop, specifics for some screens with some features, and you have a specific part for the service. So any other box could consume the same service. This works horizontally around of our app. And if the boxes can talk between themselves, they are not dependent of each other. You expected that one of these domain box, it could work alone without needed of information from outside. And then show you a little bit of our code. So this is a face of one of our domains that we have inside, so you can have a view. We have the app layer that has the activity, the fragment, the service located where we inject everything, some view holders. We have the presentation that has the model, the presenter, has some events for channels like co-present, and we have the mappers. We have the core that is very important for us to be stable, that has the contract for everything, has a domain that has the rules for the whole feature, and has the interactor where we put our business logic. And we have the data that where you communicate with your service that give you from API and rules. And here, as I'm pointing that, is very important, this file for us. This is one of our contracts. So basic, the contract, it defines 4 interfaces, 1 for each layer, and looking for the contract, you should be able to understand what your feature is doing, what your behavior that you're expecting, what you're gonna receive in return from your interactor or from your presenter, and you should not care about the implementation. So we don't wanna know how exactly you did a small part of your code, but you wanna understand about what your code is doing. Oh, sorry. This red thing that I make here are the main unit tests that we do in our code. And I like to point it out because here at Depop, we cannot pass any new feature or any new domain without unit tests. So we are always very worried about testing our maps, testing our business logic, test our repository. And just to point it out, our unit test, with this one, we are testing the presenter. So we mock everything else. We don't have any other implementation together. And this is how we have like a small test. So this is a runtime exception. The other one is just a small presenter activity that you have, a presenter method that you have that when you click, you expect that the view will be updated. And that's the granularity of the unit test that we have on our code. And then some questions that I would expected. And how about MVVM? And you have to have control of your view all the time. You need to bind it. And I kind of don't like MVP. Yeah, it's okay. But what's the trade-off that we do? At Depop, as I said, we don't hold anybody from doing anything. If you can come to the meeting, you have a good reason to use it. We can discuss and understand that would make sense for you. Since we are very modularized, we don't feel the need to use MVVM for 2 reasons. Today, the best implementation that we have on VVM, or at least the most used one, is rely in some libraries. For example, live data. So if we at some point live data is not working anymore for any reason, our architecture is compromised. And we tried so to have architecture that it don't depend in any kind of library. Another reason is that when you have an MVVM and you do a unit test and you know that your presenter is working, you are not sure that your view will update. You need to do more tests on top of it. So when we bind the view, and it's not a perfect solution on our presenter, we are sure about what the view is doing. So when we do a unit test for the presenter, we are sure that the view is being called. And this gives us control about what's happening. And thank you a lot, guys. This was a picture of our last party at Depop. Was amazing, Miami vibes. And yes, any question?